Okay, section 5.3. Here's another of the at least one problems. So, suppose there are 5 babies born one night in a hospital. What is the probability of at least one boy? So you have 5 babies, you think, what's the probability of at least one boy? This one, it would be tedious to come up with all the outcomes. You could say, well, it could have been girl, boy, 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 boy. Right, that's one way you could have 5 babies. Trying to make all the outcomes and count all the ways that there's at least one boy is confusing. So we're going to use our probability. So the probability of at least, come on, least one boy equals 1 minus the probability of no boys in 5 babies. Okay, so at least one boy is 1 minus the probability of no boys. So if you know the probability of no boys, then you know the probability of at least one boy. Again, this is an English kind of problem that you could imagine. But here, I'll make a little circle. There, that's at least one boy. I'll make a square around the circle. This represents all the things that could happen. If everything inside the circle is at least one boy, everything outside the circle is no boys. They're complementary events. So, the probability of no boys is much easier to calculate. This is the probability, so we'll do it over here. Probability of no boys for 5 babies is the probability of getting all 5 girls, right? That's the probability of getting a girl on the first baby's a girl, and the second baby's a girl, and the third baby's a girl. You do this for 5 babies. There's 5 of these, because there's 5 little babies. So because there's a girl on the first one and a girl on the second one, I'm saying and then I'm multiplying them together because they're independent events. So because they're independent babies, the probability of all girls for 5 babies is the probability of girl on the first baby times girl on the second baby times etc. So probability of the first baby's a girl is 1/2 times second baby's a girl 1/2 times third baby 1/2 fourth baby, we're getting a little ward full of girls, which is equal to, we'll just leave it as 1/2 raised to the 5th. You could also think of that as 1/32 if you like. 1 divided by 32. So this was sort of side work. 1/32. So the probability of at least one boy is 1 minus the probability of no boys. Or you could say 1 minus the probability no boys is the same thing as all girls. What up? So we just calculated that. It's 1 minus, this is the probability of all girls, right? All here, all girls, that side means girls. So 1 minus, you could say 1/2 raised to the 5th, or you could say 1 minus, now I'm just rewriting the answer in different ways, 1/32, or another way you could say this is 31 divided by 32. So clearly having at least one boy is pretty likely. Having all girls out of 5 babies is not very likely. So this is another at least one problem. At least one boy. You should be able to work something like this. So the probability of at least one is 1 minus the probability of no boys. So you go over here and you calculate probability of no boys. Because they're independent events, we multiply them together. That's 1/2 to the 5th, 1/32. We take that back over here and say 1 minus 1/32. Ta-da!